welcome back to this amazing channel. This is Abhinav. From last 2 years, I'm making these video editorials of Codeforces, Codechef and Leetcode contest. And you guys have shown a very great support in my videos. So first of all, thanks a lot for that. And these regular CP contests, participating and practicing these questions helped me also to crack good companies like LinkedIn, Zeta, and Geeks for Gigs. And this all was possible because of a proper mentorship and because I solve these problems regularly. I do upsolve the problems and I do solve problems of lead code and code force. So if you're also someone who is preparing for CP, who is preparing for interviews, who is searching for internship, but facing difficulty with you're not able to increase your rating, you're not able to solve problems regularly, if you are facing any such difficulty, we have recently launched Coding 75 Pro, where we provide one-to-one mentorship sessions and live classes of CP contest discussions, DSA classes, live project building classes, and CS fundamental classes. So it's a complete pack of your interview preparation. So if you are watching this video editorial of Codeforces, Codechef, and Leetcode, and if you want to also join the live discussion of these same contests with me, along with that, if you want one-to-one mentorship with me on CP, on DSA, on interview preparation, or in general anything that you need, you can check out the Coding 75 Pro subscription. The link is in the description. The whole schedule of the course is also present in the description. You can check that. The cost is very efficient, just 499 per month. That's it. But if still you have any doubt regarding our Coding 75 Pro subscription and how it can help you, you can DM me on my WhatsApp number, which is given in the description. You can DM me directly. We will talk about what are the difficulties that you're facing and how Coding 75 Pro can help you. So do join it now. Thank you.
Hello guys and welcome back to this channel. In this particular video, we'll discuss about the problems of contest 945, which is actually a Div 2 contest of Codeforces, right? In this particular contest, we will solve like 3 problems only. Actually, I was not able to take part in this contest. Okay, so I do up solve the problems, all the 3 problems, and now I'm making this editorials. Actually, the contest was a good level. Both the problem B and C were of good level actually. A was a pretty easy problem, but again some logical thinking was there. Let's solve all the problems one by one. The first problem is that there are 3 friends. Okay, let's say the friends are A, B, and C, and they are playing a chess game, right? They are playing a game of chess. The thing is, when someone wins the game, he gets 2 points. When someone loses game, he obviously get 0 points. And when there is a draw, both the person gets 1 point, right? That's the thing. Now there are some 3 combinations given to you: P1, P2, P3. There are 3 values given to you that actually represent the score of, let's say person A, person B, and person C. Nothing is that P1 will be less than equal to P2, less than equal to P3. Means P3 is the greatest one here. We have to tell, okay, with this score combination, what are the maximum number of draws that are possible? Maximum number of draws that are possible. Okay. And secondly, if it is possible or not. Like if it is impossible for that particular number of draws, then say -1. For example, if the 3 values given are, let's say 0, 0, 100. It is impossible now. It can never happen ki, okay, sorry, this is possible, by the way. This is possible. Let's say it is 101. This is impossible. This is impossible, because see, the third player can get 101 only if there will be a draw. There will be a draw, and draw will be some other person only, either A, either B. But you can see both A and B have 0, means they don't have any draw and don't have any win. They have only losers, right? So this can never be happen. So the basic thing is that the sum of P1 plus P2 plus P3 should always be even. That's the very first thing. If it's not even, that means that there is not a, that it is impossible, to have a combination of matches, because it should not be odd, it should be even. So if it is odd, if it is odd, it should be impossible. Why it is odd? Because see, after every match, 2 scores are added to the people's score, right? Either it is added 2-0, either 0-2, or either 1 1. So if A and B are having matches, if A will win, A will get 2 score. If B will win, B will get 2 score. Or either both of will get 1 1 score. So in every match, a score of 2 will be added. So final score should also be a multiple of 2, means it should be even number. So if the final score means the sum of these three is odd, that means the answer is never possible. That's the very first case that we have to consider. Second, you have to find the maximum number of draws that they can have. Maximum number of draws that they can have. Now let's say that A has won 4 matches, like A has a score of 4, not won 4 matches, A has a score of 4, B has a score of 6, and C has a score of, let's say, 8. Up here, if you will see, how many draws can have? Up, let's say all the matches of B are draw. Let's say all the matches of B are draws. So what will happen actually? So if you will see, means there are 4 matches of that A has played. Out of this, all the 4 are draws, right? Similarly, let's say for B, up these draws are with which a person. Let's say these draws were with B. So B also has 4 matches. So basically 4 matches were there between A and B, which were all the draws matches. That is why A also got 4 and B got 4. And remaining 2 B got, let's say, with draw matches of C. Okay. And remaining 6 matches of, remaining 6 score of C, maybe he has got after remaining 3 matches. So this is how the combination can happen. But which combination will give you maximum answer? Because if you will see here, in this combination you will having just 6 draws. But if you will see a combination, let's say there are 4 matches between A and C, 4 matches between B and C, and they all are draw. If you will see, तो क्या होगा? 4 points A will get, 4 points B will get, and 4 plus 4, 8 points C will get. And remaining 2 points of B, let's say, is by a win, is after a win. So this is how you are having 8 draws, right? So if you will eventually see how many draw matches we can have, either divide the whole score into 2 and assume that all the matches were happening, as draw, like the whole score is because of draw matches only. So if the total score is, let's say, sum, which is P1 plus P2 plus P3, so sum by 2 will be the number of draw matches that happen. That okay, there will be sum by 2 draw matches happen, and where every person got 1 score. But this will be false when only one player has more than half. For example, here if you will see, the total sum is 18. Total sum is 18. Okay, yeah, and half of 18 is 9. But none of them is having, more than 9. So actually, 9 can be the draw matches that can happen. So the eventually the formula will be, if you will see, that you will first find the sum of the vector. First of all, if this sum is odd, -1, else it will be minimum of sum by 2, because here we are considering all the matches are, draw. So sum by 2 matches will be there. Else we will say it will be sum of V0 plus V1, means 2 minimum of 3 scores. Why I'm saying that? Because let's say agar A, B, C hai, let's say C is 100, A is 2, B is 2. So sum by 2 will be actually 52. But 52 draw matches cannot happen. Maybe 2 draw matches it can play, 2 draw matches it can play. There can be only 4 draw matches. So in this case, when even like actually ये बहुत छोटी वैल्यू है, but sum by 2 is very large, means even A and B combined cannot play these draw matches with C. So your value will be basically minimum of this A plus B ka score, comma sum by 2 value, whichever is minimum will be your answer. So you can see that is what I've done. Okay, so this is how we are solving this problem. Next is a problem, guys, where they are saying that you are having an array, and in that array you are having like you have to basically find loneliness of array. What is loneliness? Loneliness is a value k. It is a smallest positive integer k, such that any two positive integers I and j hold this condition. The condition is that the bitwise OR of values from ai to ai plus k minus 1 and aj to aj plus k minus 1 should be equal. Basic thing is, let's say there is an array given to you. Let's say 5 3 1 8 7 6 2 1. Okay, and let's say we are checking for k equal to 3. The thing is that for every sub array of size 3, this, then this, then this, then this, then this, and this. इसका मतलब यही है कि फॉर एवरी सब एरे ऑफ साइज k their bitwise or value should be same. That's the main thing. For whole array, for every sub array of size k, their bitwise or value should be same. So that is what you have to find, and you have to find the smallest possible k. ठीक है. Up we will solve this problem using binary search, guys. But before applying binary search, we will first see ki how we can actually check that for a particular value k, let's say, how we can check that whether it is possible for that particular k to have, the all the survey having same bitwise zone. For example, we are checking for k is equal to 3. Up you have to find the bitwise XOR for every subarray. You have to find for this, for this, for this, for this, for this, for this. For every subarray you have to find. If you will apply brute force for every subarray of size k, you will check it will take order of n into k type time complexity, right? Instead of that, what I will do is I will actually apply sliding window here. Okay. Now how I will apply sliding window? See, first of all, let's write these numbers as bitwise numbers, right? As their binary implementation. So 5 will be 0 1 0 1, 3 will be 0 0 1 1, 1 will be 0 0 0 1, 8 will be 1 0 0 0, 7 will be 0 0 0 1 1 1, 6 will be 0 1 1 0, 2 will be 0 0 1 0, 1 will be 0 0 0 1, right? So these will be the basic thing. Ab next what we will do is it will be 0 1 0 3 4 5 6 7. Okay. Now we have to find bitwise XOR for every, right? Now what is bitwise XOR? Bitwise XOR is that, let's say if we find bitwise XOR of this, it will be 0 1 0 1 0 0 1 1 0 0 0 1. It will be 0 1 1 1. So if at a particular index any bit is set, the final bit will also be set. So in bitwise XOR, if any of the number have that bit set, in the final result that bit will be set, right? अब देखो, we have to find the bitwise XOR for every subarray of size 3, and then check whether they are equal or not. Instead of that, what I will do, I will actually take, first of all, I will take a array called frequency array. This will actually store the frequency of all the bits. So currently you can see all the numbers are 5 bits number. So I'm just taking 5 bit, or actually 4-bit number only. So I'm just taking array of 5. Otherwise we will take an array of 22, because the numbers that they are telling us are up to 20, 21, right? Now what I will do, first of all, for the first k numbers, I will find, okay, for this first k numbers, which bits are actually present and how many times they are present. By the way, we have to just see which are present, because if a bit is present any number of time, that bit will be set in the bitwise OR. But I'm also checking how many times they are present. That actually there is a reason for that. So for example, if you will see, this first bit is not present any number of time. It is closed in all of that. This second bit is actually present only once. This is present again only once. And this is actually present 3 times. So means ki in the first k numbers, you will see that these 3 bits are set and remaining are not set. Means the XOR of these first k number is this. अब this should be the XOR of all the other numbers also. First k numbers का XOR है, तो बाकी भी for every window this should be the XOR. But how you will find the XOR for every window? For that, what I will do, I will use the concept of sliding window. What I will do, initially this is the XOR for the first k, right? Now what I will do, I will move my window forward like this. Now when the window is moved forward, this new number at index number k is added, and this number at index I minus k. So this is, let's say, index number I, okay? So this number at index number I is added to your window, and this I minus k is removed from your window. Am I right? It is removed from your window. So what will actually happen is, if this is added, all the bits of this will be increased. So like here 1 bit is present, okay, and none of them are present, and this will be decreased. So means this first bit will be decreased to 0 and this will also decrease by 1. That means कि इस window में these are the frequency of the bits. So you can see this is present, this is not present, 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 present. Means bitwise OR of this window is this, which is actually not equal to the previous window. You will simply say answer is not present. But if similarly, next you will find for this, you will find for this. And if bitwise OR for every window is actually equal to the first window, that means for that k value is possible. If you will see here, what I'm actually doing is I have written a check function. In a check for just like here I have took a this array bits array of size 5. Here I have taken size 22. Okay, and this bits array for the first k numbers, you can see just for the first k numbers, I'm actually storing how many times a particular bit is present in the numbers. So I'm storing the bits. So you can see that like that's the basic code of how I'm checking that for number x, if the bit is present, increase that particular bit in this array. Okay, now for the remaining numbers from here to here, for remaining numbers like from here to here, for first window, the next window, the next window. Okay, as we will go on, we will take a number which is vi. So I will add a new number vi, and for the new number vi I will increase the frequency, and for the number vi minus k, I will actually decrease the frequency. So for vi I will increase the frequency, for vi minus 1 I will decrease the frequency. As I said, इसके लिए increase हो गया, इसके लिए decrease हो गया, right? And this I will do for every, like next यहाँ पे जाएगा तो ये increase होगा, ये decrease होगा. This will be I and this will be I minus k, right? And for every I will also check that for every window the frequency in that window should be also equal to the first frequency. तो ये जो है ना, ये हम इसको frequency array मान रहे हैं, where we are making changes in every window, and this is the bits which was for the first k elements. So you can see this bit was the first k element, and using that bits only I have created frequency where I will do the changes for every window. And for every window I will check that okay, the values in that frequency window should also be equal to the bits window. Not exactly equal, I'm not saying equal, but the bits which are set in the frequency window should also be set in the bits window. So, but problem कब आएगी? Let's say there is a bit I which is 0 in the bits window, but it is greater 0 in the frequency window. Means in the or वहां पर वो 0 होगा, यहाँ पे 1 होगा. Or if there is a I which is 0 in the frequency window but more than 0 in the bits window, then also it's false. So these both are the cases of the false for any of the case. Else if everything is fine, we will return true, right? And now we will call this check function for all the possibilities. It's a binary search we are doing. So the lowest value possible is 1 of k, highest value possible for k is n. N से बड़ा नहीं हो सकता, right? So for low as 1, high as n, I am applying binary search. I am finding mid. For this mid I am checking that whether it is possible or not. If it is possible, I will make my mid as answer, and now I will search for a more smaller value, because you have to find the smallest k. And if it is not possible, try to increase the value of k. Okay, so that is how we are solving this. This is a complete problem of binary search. So if you have any doubt, you can ask me. Okay, also guys, I have prepared a sheet of 150 plus CP problems. It is a sheet that contains all the problems from newbie to expert level. It's a CP expert sheet, and very importantly, this sheet contains all the problems of this sheet contains video editorials by me. So if you want that sheet, do DM me on Instagram. And I will actually share with you the link of this CP expert sheet where you can go and solve problems with every problem having my video editorial. Cool. So guys, also if you have any doubt, you can ask that to me in the comment section, or you can join a Telegram channel to ask it out. Okay. Now guys, let's move forward to the last problem. Problem number C for this video, which is cat, fox, and double maximum. The problem says that you are having an even positive number n and a permutation of length n, right? Now you have to actually create a permutation q such that there is an array where each element of array is the summation of element at p plus summation of element at q, like basically p plus q. Just give me 1 minute. Just give me 1 minute. So sorry, guys. So sorry for this interruption. Uh, I will not edit this part here. It takes a lot of time in editing. But yeah, we can continue to the next problem, the last problem for this video, which is cat, fox, and double maximum. The problem says that you are given a even positive integer n and a permutation p of length n, and you have to find the permutation q such that there is an array A whose every element is a summation of p I and qi, right? And also this A has maximum number of local, like maximum number of local maximums, right? You have to maximize this score, right? So basically, for example, you can see for this p permutation, they have given this q permutation, and they are saying, okay, this q permutation actually have the maximum value of local maximas. Okay, what is this maximum value of local maximas? uh, so for example, p is 1 2 3 4. They are saying q can be 2 4 1 3, such that जो A आएगा that will be 3 6 4 7, and this 3 6 4 7 will have one local maximum of this. Local maximum means a value which is greater than both of its neighbor. देखो ये भी इसके इस वाले नंबर से बड़ा है, but there is no right neighbor, so भी it is not a local maximum. So both the neighbors should be present. Means internal elements will be only the local maxima, right? Similarly, you can see for the array like this, 1 2 4, what they have given. Yeah, so for the array like this, and like this, so I will, yeah, so you will see if this is p, this is p, this is q, so A will be 6 6, it will be 6 and 6, then 12, then 7, then 14, then 7, then 14, then 6. So here they are having 1 2 3 local maximas, and it cannot be more than 3 according to them, right? So see guys, how we can actually do that. Okay, how we can actually find these local maximas ki, okay, a q such that we have maximum local maximas, right? Now guys, very important thing that we are having here is, for example, let's take the example of the same p, maybe some better one. Let's take this one. Okay, let's take this one as our example. Okay, up here what will actually happen, this is our p, right? So this is our p. Now guys, if you will arrange the numbers in this way, if for 1 we will have 6, then 5 4 3 2 1. Okay, in this case every value will be equal, every value will be equal, which is equal to 7, which is actually equal to n plus 1, because n is 6 here. So we can rearrange the queue in such a way that every value is equal to 7, which is equal to n plus 1, and in this way there will be no local maxima. So obviously this is not the answer, this is not the answer. There will be no local maximum in this particular case, there will be no local maximum. Then what should we do? So guys, okay, in this case there will be no local maximum. Also, you cannot always make values very large. For example, if you will say, okay, for this 5, I will add a 6 here, the largest number, so that this will become a local maximum for sure. But this will not guarantee the others number will become local maximum, because if you will put all the maximum ones, this can also be done. Like people will think, okay, मैं 6 में से 6 रख दूँ, 1 रख दूँ, 1 4 2 3. In this way, actually some local maximum will be built. If you will see, this is a local maximum. That's it. Maximum number of local maximum will not be there. So the thing is, see, this is right. This is fine. If you will put values in this way, actually, like this, so you are getting sum equals 7, which is n plus 1. What I want to decrease some values by some point and increase some values by some point. Currently they all are n plus 2. Increase by how much and decrease by how much? So see, I will try to increase some values by 1 and decrease some values by like corresponding. तो अभी क्या है, अभी all the values are n plus 1. अब what I thought at that time was कि okay, what we will try is we will try to make some elements to n plus 2, so that some elements will become n plus 2 and remaining will become less than n plus 1. So there will be a local maximum, and also this local maxima should occur on alternate part, because they cannot occur consecutive. अगर यहाँ पे local maxima है, so next should occur here only. In between it can't occur, right? It can't occur because it happens like this, right? It cannot go like this. No, that's the main thing of local maxima, right? So up either it can happen in what, in odd indexes or either in even indexes. Where should we target local maxima? Means where should we target to make sum equal to n plus 2? Where should we target that? Either in odd indexes, either in even indexes, right? Ab the thing is, we can never make this index where 1 is present equal to n plus 2. We can never make, because if you have to make the summation of this index equal to n plus 2, you have to add n plus 1 here, which is not possible. So the index where 1 is present can never be made equal to n plus 2. So basically the parity of the index where 1 is not present. So you can see 1 is present in the even index. Means this index I cannot make equal to n plus 2. So then I will actually try to not make any even index equal to n plus 2. That will not be a target to make local maxima. Now my target is to make these indexes which are not even as local maxima. 5, 4 and 3. Local maxima means value equal to n plus 2, which is 8. अब देखो, when you will make 5 equal to 8, you have to add 3 here. When you will make 4 equal to 8, you have to make 4 here. For 3, you have to make 5. So that you can have 8, 8, 8 for all of them. And now ultimately you have to make these values less than 8. But they will become less than 8. But in some case they can actually become more than 8. How? In what case they will become more than 8? Let's say, see, you have taken 3, 4, 5 here. Remaining values are actually 1, 2 and 6. Now if you will actually add this 6 here, 1 and 2 here, this will actually give you 12. So now this will not remain a local maxima. No. So now these values will add in the order of the decreasing order as per the value. So जो सबसे छोटी value है सबसे बड़ा जाएगा. This is 1, here 6 will come. This is 2, here 2 will come. This is 6, here 1 will come. So final summation will be, इसका हो जाएगा 7, 8, 7, 8, 4, 8. This is how it will happen. Now in this case you can see we got the two local maximums. So did you got the agenda? What's the logic? Let's take the one more case. For this, let's say. Okay. So I will basically try to make numbers n by 2, and that is how I will try to make local maxima actually. That is why I will try to make local maxima. I will try to make local maxima equal to n plus 2 for every. अब देखो यहाँ पे क्या है, यहाँ पर 1 is present at what index? So 1 is present at 0 index. Again at even index 1 is present. So if 1 is present at even index, for odd indexes I will try to make their value n plus 2. And how to make them? Let's see. अब मुझे अगर इसको n plus 2 करना है, n is 8, so here 8 should be there. For this, for 10, 5 should be there. Here 4 should be there, 7 should be there. So this is how you can see. These all the values will become 10, 10, 10 and 10, which is actually n plus 2. When you made these values n plus 2, now their remainders can never become more than n plus 2 or equal to even. They can even not become equal to n plus 2 because average was n plus 1. If you made some values n plus 2, remaining will become less than only. But the case when you will actually arrange the value in a good way. So you can see we have added values 4, 5, 7, 8. Values 1, 2, 3 and 6 are remaining. Now, as I told you, you have to assign this value in the reverse order of their assignment. So it will be 6, 3, 2, 1. अब देखो यहाँ पे 7, 7, 9, 9, which is actually less than 10. They will never go more than or equal to 10. So this is how we have to actually assign the queue to get the answer. अब how we can actually do this? This is a great simple observation based thing, but how we can actually achieve this? How we can implement this logic? That's also a good thing, right? So if you will see my submission, what I have actually done is कि okay. So see, what I'm doing first of all is I'm first of all taking two vectors, P and Q. Initially all are zero. Like obviously, one P is there, one Q is there. P will get the input, Q will actually assign, right? Now, and अब देखो, two more things are there. Vector pair is there, I will tell you what's the need of that, and there's a set. अब this set will actually initially contain all the numbers from 1 to n. So like 1, 2, 3, 4, 5, 6, 7, 8. All the numbers it will contain, right? Basically, it will store which numbers are remaining and which are actually taken by the queue. Okay. अब देखो, initially my current is -1, current is like nothing, so we are actually taking input of py here, and this current will actually store the index where this 1 is present. Because the index where 1 is present, we can't make that indexes to local maximum, right? So you can see here current is present at index number 0. That means even indexes will not make local maxima, we will make odd indexes local maxima, right? So up simple your for loop will start. Understand very carefully here. I will iterate through all the indexes. Up see, for an index which is mod 2 is not equal to current mod 2, means if current is even and that index is odd, or if current is odd and that index is even, means their parity is not same. If they are not same, that means you will make this index as what? Local maxima. Local maxima means you will make the value of qi plus pi for that index equal to n plus 2. That means the value of qi will be equal to n plus 2 minus pi for that particular index. And that is what I am saying. For that index, I am saying qi is equal to n minus pi plus 2, which I written here, right? And also because I have considered this particular qi value, I will erase it from set because you have taken that value. So you will erase it from the set. You will erase it from the set. So what will happen actually? Let's say, so for even indexes we will not take. For odd index, which is here, you will make 8 here because you want sum as 10 and plus 2. 5 will come here, 4 will come here, 7 will come here, right? This will come. Up what will happen? For the indexes which have same mod value with like current, which is else case. Else case what we will do, for all those values, I will insert it in a vector pair with the value and its index. So basically in the vector pair what will happen? So this 1, 0 will be inserted, then 4, 2 will be inserted, then 7, 4 will be inserted, and then 8, 6 will be inserted, right? That will be the case. Now next what will happen? Next we will sort this vector on the basis of comparator. This comparator is basically simple. You have to sort the vector on the basis of decreasing order of the first element. So first element की decreasing order it will be sorted like this. 8, 6, then 7, 4 according to first element, right? Then 4, 2, then 1, 0. Why I'm doing that? Why we are doing that actually? So the agenda is, let me explain you. Now this vector is gone. अब agenda is when we will actually assign, to assign these values, as I told you, कि the value, the index which is having the largest value, here the smallest value should come. So because we have a sorted and decreasing order, this first element is the index where the largest value is present of V. So वहां पर at that particular index where 8 is present, which is index number 6, I will put the smallest value of the set which is currently available. So you can see set में हम लोग ये delete कर देंगे. So 8, 5, 4 and 7 are deleted. You can see we are erasing it from the set. So main remaining are 1, 2, 3, 6. So at 8 we will put 1. Then at 4 we will put 2. Then 3, then 4. Okay, because we know कि okay, first element पे in the P there is a larger element. So in the Q we have to put the smaller element. Reverse of it, right? So you can see I'm iterating through the set, and for each number what will be the thing? So I am saying V of Gi is second. So whatever is the second value of the current index of Vi, at that index I am storing I. जैसे हमने क्या किया, 1 कहाँ पे गया, 6 पे गया, 2 कहाँ पे गया, 4 पे, and so on, right? And then finally I am printing the value of Q, and that's it. This is your answer, right? So guys, this is how we are solving this particular problem. If you still have any doubt, you can ask that to me in the comment section, or you can join Telegram group to ask your doubts. Thank you.